All right, so our homework for tonight is to watch this video and get ready for tomorrow, where we're going to add and subtract vectors, real world situations of things representing, vectors representing real world. So let's go through this step by step. So we have this situation. A boat is traveling 16 miles per hour at a direction 30 degrees north of east. The water is moving, so we've got the boat, got the water. Okay, we'll let U represent the boat and V represent the water. Water is moving 10 miles per hour, 15 degrees west of north. What is the actual speed and direction of the boat? We want the speed, we know is the magnitude, and the direction, which is theta. Okay, so we know this is going to be the resultant vector, and this is going to be theta. All right, so let's draw them separately. We won't always do this, but we're going to start out that way. So the boat, 30 degrees north of east. So we've got north and we've got east, and it's starting at east and going 30 degrees north. Okay, and so this vector is 16 miles per hour, right? This is the boat. There it is. Okay, that's the starting vector. So let's transplant that on to our boat here. It's a cute little boat. So we're going to say this is vector U. It's 16 miles per hour, and this is 30 degrees. Okay, that is both theta and theta prime. Remember that that's my most important thing that I need to figure out here is what is theta. And so this is 30 degrees, which equals theta. All right, let's look at the water. The water is moving 10 miles per hour, 15 degrees west of north. Okay, so we've got west and north. And I'm moving 15, I start at north and I go 15 degrees the other way. So this is my water, it kind of has a vector. This is 15 degrees. The magnitude of the water is 10 miles per hour, okay? Now, this is not theta prime. This is theta prime, so I'm going to draw this 15 plus what is 90? Well, that's 75 degrees. So we know that theta prime equals 70 degrees, but that is not theta, and that's the important thing. So we are in quadrant 2, so theta equals 180 minus 75. Theta itself is equal to 105 degrees. So just, this is really what gets people right here. So let's add the water pictorially to the boat. So I'm going to draw this vector, start here, and I'm going to draw like a horizontal dotted line. It's not a real line, but here's where I'm starting, and I'm going to take this vector. This is tail to tip. I'm going to go tail to tip. I'm just moving this vector, okay, and it's 10 miles per hour, so it's less estimated. And let's see, so I'm just giving an approximation here, but here we go. I know that this vector has this much rotation from the horizontal, which would be 75 degrees. I know its actual theta is 100, okay? So there I've drawn my situation. So what's the actual speed and direction of the boat? Graphically, it's the beginning to the very end result. And there it is. That is the resultant vectorially. All right, so we know one. Let's go through the process. Find the components for vector U. All right, well, for vector U, okay, this is going to be A, and this is going to be B for vector U, which is the boat. So the boat has theta of 30 degrees and magnitude of 16. So it's 16 cosine 30 degrees and 16 sine 30 degrees. Okay, and so my components are just going to be, get out your calculator, and 16 cosine 30, 13.86. Let's just do it in places. We're going to say 13.86. And then 16 sine of 30 is 8. Okay, this is the component for vector U. That's the answer. Now, the component for vector V. We're going to do the same process, but with the water. The water is moving 10 miles per hour. The cosine of for the water is 105 degrees. And then 10 sine 105, x component, y component. Let your calculator do the work. Plug that into my calculator. I get negative 2.59 and 9.66. Makes sense because this vector was heading second quadrant. I'm going to add it to this vector to get my resultant. So my resultant vector is going to take the first components, 13.86, comma 8, add it to the second vector, negative 2.59, 9.66, okay, to get the resultant vector. And that's going to be 18.66, and I'm going to subtract 2.59 to get 11.27. This is my resultant vector. I am not done though. First of all, the actual resultant vector, but I need the magnitude of this vector and the direction. Okay, so I need the magnitude r and theta. Okay, so we know how to do that. So for the magnitude of the resultant vector, we just square root of these two components, 11.27 squared plus 7.66 squared, and magnitude's positive, right? Because whatever you square, you're going to get positive. So here we go. We just say let you calculate the square root, 11.27 squared plus 17.6 squared, 20.95 gives me a magnitude of 20.95. And because we're good mathematicians, we know that that has to be right, and that is miles per hour. Okay, so there's the magnitude of the boat. Excuse me. All right. We know that theta equals the inverse tangent of B over A, which is the inverse tangent of 17.66 over 11.27. One case, we're going to have theta prime, and then we're going to apply the quadrant rules. Okay, so these are always positive. In case they are positive, but don't forget that one. Okay, so let's use that. The inverse tangent of 17.66, the y value divided by 11, gives me 57.5 degrees. That's theta prime. Now, in this case, we're going to do the quadrant rules. We're in quadrant 1, so theta equals 57.5 degrees. So these problems are a bit complex, but we're just going to go through them. All right, let's do the back of the notes. So a hawk flies 20 miles per hour at a compass heading 30 degrees west of south. I'm trying to find theta. Okay, I've got vectors, the hawk and the wind. Here's the hawk. 20 miles per hour is the magnitude, 30 degrees west of south. Start at south. I'm going to go 30 degrees toward the west. That's going to be 20 miles per hour. Okay? Now the wind, I'm going to do the wind in blue, is blowing 5 miles per hour at a direction 10 degrees west of north. The wind here. We've got north and we've got west. Your wind is 10 degrees west of north. Start at north. I'm going to go toward the west. There's my wind vector. Okay, and it is 5 miles per hour. 5 miles per hour. Okay, so pictorially I could start here and just draw a vector that's going like that. Okay, that represents the wind. I just transported it, and now I can see a big idea. What's my resultant vector going to be? Well, my resultant vector is going to be in the third negative, negative, and I got to work to see the actual numbers. Okay, so let's get the components of both. First we have the hawk. The components, remember, are the v cosine magnitude u magnitude v sine theta. That's what we're okay. So of the hawk is 20 cosine, what was theta? We're looking here, oops, we didn't figure out theta. The hawk in red, okay? And we said that this value right here was 30 degrees. That is not theta prime. It's not theta or theta prime. So let's figure out what, in this case, what theta prime is the amount from 0, hawk. Theta prime equals 60 degrees. We're in the third quadrant. So theta itself is going to equal 80 plus theta prime, which is going to equal 240 degrees. Okay? So the hawk is 20 cosine 240 degrees. And 29 240. Okay? So I apologize for not doing that right when I drew the arrow, but while you draw these, find theta. We see 30, we know how to get theta itself. Okay? Oh, all right. For the hawk. Let's do the wind. So let's do the wind and do the same thing for the wind, and then we'll calculate them both and add them together. Okay? So the wind is blowing at miles per hour. Cos theta for the wind. Well, the wind was this vector right here. We said 10 degrees west of was 10. So theta prime for the wind, okay, is 80 degrees. Theta prime equals 80 degrees. In the second quadrant, theta equals 180 theta prime. So theta 100 degrees. So 5 cosine 100 degrees and sine 100. All right, so we're going to further calculate. We're not going to draw a line because we just got the hawk. And let's use our calculator, okay, to get these values. Once we get them, they'll be numerical. We'll add them together to get the resultant vector, okay? All right, my calculator, 240, and that's going to be negative 10. And I do 20, and I get negative 17.32, right? The hawk. Now I'm going for the of 100 is negative 0.87, and the 5 is going to be positive 4.9. Okay? Now add these together. And when I add these two together, they're going to be negative 7, because they're two negatives, I just add them together. And then I have a negative and a positive, so it's going to be negative 12.40. Okay? So we evaluated the components with the magnitude and the direction, and then we all the x, and then we add them together. So we have the vector. We need the magnitude of r. So the magnitude equals the square root 10.87 squared plus 12.4 squared. And I'm not worried about square it, it's positive. So right now we're only caring about magnitude. So when I plug this calculator, 16.49 miles per hour. 16.49 miles per hour. That is the magnitude of the speed of the hawk. That's flying. Now I want the direction. Prime is equal to the inverse tangent of b over a. Worried about the positive values now. 40 over 10.87. Theta prime on my calculator. 48.8 degrees. But I'm not done. Negative in quadrant 3. Rule for quadrant 3, 180 plus theta prime, 228 degrees. Magnitude and direction. All right, there's one. So we've got two jet skis working on a boat. So we've got all three vectors. So they're working together to pull a broken down boat. One jet ski is a force of 230, so we'll call this boat A. Okay, so 230 pounds. While the other jet ski is of 190 pounds. The angle in the jet skis, this angle is 40 degrees. Okay, it's 40. what we do when we have this situation is we draw as if the boat was heading directly east. We don't really know this is so far, but pulling on this jet ski. So let's just divide it in half. Okay, there we go. So is that this is theta for boat A. Okay, theta B is going to start here and remember come all the way around, right? So about jet ski A, okay, this is the first jet ski. What's the magnitude? The magnitude of A equals 230. What's theta? Theta of A equals half of 40, so 20 degrees. Jet ski B, B. The magnitude of B is given to us, which equals 100 pounds. Let's label them pounds. All right, well, let's just think for a second. This boat has theta. We know theta prime is the distance to the horizontal. But what is theta? Well, we know the 4, so we know the rule itself. It's in quadrant 4. So theta equals 300 minus 20, which is 40 degrees. Okay, 340 degrees. So now I have important quantities, theta for B, and I can add these two components together. Okay, let's do that work. So what we do is we have A, and we take magnitude 230 times the cosine of theta, 20 degrees, and 200 times the sine degrees. Now let's do B. I'm going to do B in red. In jet ski, the mag 90 times the cosine, now different theta. Theta is 340. So 1 times the sine of 340 degrees. Components of my first jet ski. Now I'm going to calculate them on my calculator. Again, A. And I'm going to get the 10th place, 216.1 and 6.7. Calculate the components for B. I get 107.5 and 64.9. And that's like what I was expecting, because this is in the positive negative in the. And now what I'd like to do is add them.